Alright, in this video, we're going to look at how to use the scale factor to find area and volume. Because just because the scale factor is, say, 1 to 4, that doesn't mean that the area scale factor is going to be 1 to 4, or the volume scale factor. In fact, alright, let's go to the black screen for a second. Here's how the scale factors are related to each other. We've got length, and we've got area, and we've got volume. So for example, let's say if the length scale factor was 2 to 3. And in general, if I just say scale factor, it automatically means the length scale factor. Who remembers how I can use that to come up with the area scale factor? Okay. Right. To get the area scale factor, you square the length scale factor. So what would the area scale factor be? Right. The area scale factor would be 4 to 9. All right. Now, the volume scale factor, you again have to look back to the length scale factor. All right. You don't get it from the area. You go all the way back. So what would be the volume scale factor?
8 over 27.
Correct, because you have to cube it for volume. And it can help you remember, if you think about units, the way that in length, if I had, for example, meters, area would be meters squared, and volume would be meters cubed. Those units will help you remember what to do. Okay, so that would be 2 cubed is 8, like Christian said, and 3 to the third power would be 27. So this is the type of thing you have to do. Okay, so on this problem, number 13, it says we have 2 spheres with a scale factor of 1 to 4. So when they say scale factor 1 to 4, let me just zoom in for a second. When they say scale factor 1 to 4, they're talking about a length scale factor. Okay? Okay, so the length scale factor is 1 to 4. So if the length scale factor is 1 to 4, what's going to be the area scale factor?
1 over 16.
It's going to be 1 over 16. All right, because 1 squared is 1, 4 squared is 16. So that's going to be my area scale factor. So if I want to find areas, I'm going to have to use my 1 over 16 instead of my 1 over 4. Okay? So then what do they say? The smaller sphere has a surface area of 16. Okay? So as I set up my proportion, 16 will be the smaller surface area. And then it says find the larger surface area. Okay? So that would be, I'll put A for area. All right? But that bottom one is going to be that larger surface area that we need. So it's just a matter of solving this proportion, and that's how you do it. So if I cross multiply, it's actually pretty simple because I have A times 1 is just A. So then it's just whatever 16 times 16 is. All right? Anybody already do it? 256. Okay, so 16 times 16, 256. And on word problems, don't forget your units. So we're talking about area, so square feet. So we'll put feet squared. All right, so that would be your answer for number 13. Any questions on it? All right, usually on a video I don't get to ask are there any questions, so it's fun for me. Okay. Number 14. 2 similar triangles have areas of 27 and 16. Okay? If a side of the larger triangle is 12, find the length of the corresponding side of the smaller triangle. So look, guys, we have to sort of work backwards this time. So I'm going to make a little chart. So this time, they gave us the area scale factor first. and we have to work backwards to find the length scale factor. So the areas were 27 and 16. All right, so I could say if I'm just going to go larger over smaller. So that's going to be 27 over 16. Let's see. I'm going to pause. Okay, so this is a little bit of a mean problem. I actually think whoever made this problem messed up, and they were thinking of a perfect cube because of that 27. I actually think they messed up and accidentally gave us a number that wouldn't be a perfect square. Because normally, let me go to the black screen. For example, on a problem like this, here's a normal type of problem. Normally they might give us something like, okay, the area scale factor, one area is 9 and one area is 25. And then we have to find the length scale factor from that. But you should be able to do that in your head, right? If the area scale factor is 9 over 25, can you guess what the length scale factor would be? Anybody? Right. What number would I have to square to get 9, guys?
3.
That would be 3. So the length scale factor up here to have a 3. What number would I have to square to get 25? It would be 5. Okay? And yeah, if it wasn't so obvious, you could think of it as taking the square root of these. Okay? You could think of it as, okay, if we have 9, then we need to do the square root of 9 for length, and the square root of 25. Okay, you could think of it that way. Now, unfortunately, on this new problem, the actual problem on the paper, 27 is not a perfect square. So if I want to find the length scale factor, I'm going to have to do the square root. So it would be like this, square root of 27 over the square root of 16. Okay? If you put square root of 27 in your calculator, what's the first thing that it says? Not the decimal. What does it say? 3 square root 3. Okay, so the length scale factor is 3 radical 3 over 4. Okay, let me just show you on here. If I did the square root of 27, that's 3 radical 3. So this must be the length scale factor, and this is what we're going to have to use. Okay? Don't make it into a decimal because that's rounding. That's rounding. So now I'm going to go ahead and it says, all right, if the side of the larger triangle is 12, find the smaller. All right. So remember, I'm doing big over small. So the larger is 12, so I'll put that up there. And I'll just call the smaller one x. So it's just a matter of solving this little proportion. Okay? So I'm going to take this and copy it where I have more space. So if I cross multiply this thing, I'm going to have 3 radical 3 x equals, now I'm doing 12 times 4, so that's 48. So how am I going to get x? Yeah, I'm just going to divide by 3 radical 3 on both sides. Okay? And that's going to give you your answer. And then you can round at the end. So 48 over 3 radical 3. I heard 28.07. Okay? So that's the exact answer if anybody ever needed it. Wait, why am I getting something totally different? 48 over 3 radical 3. You got this? Do you understand what you did wrong? Okay. should be getting 9 point, did it say how much to round to? Say 9.24. Okay, so that was a little ugly. And the units will be centimeters. All right, one more. Let's see if they're any nicer with number 15. All right, the ratio of the perimeters, okay, is 1 to 3. So when they say perimeter, are they giving me length, area, or volume when they say perimeter? Yeah, perimeter is just a length. It's just a length. Okay? So they're giving us the length scale factor. All right, so we have length. And then they're asking us about volume. Okay? So the ratio of the perimeters is 1 to 3. So that's my scale factor. And so that's small over big. Keep that in mind. Small over big. Excellent. If I want the volume scale factor, I'm going to have to cube this. Okay? So that's why the volume scale factor will be 1 over 27, all right? 1 cubed is 1, 3 cubed is 27. So this is what we will use to find the volumes. And then they say, all right, the volume of the smaller triangle, how can a triangle have a volume? Okay, whatever. I think they meant pyramid, maybe. Pyramid, not triangle. Anyway, the volume of the smaller triangle is 5. So am I gonna put that in the numerator or the denominator? The numerator. I got 1 over 27. That's small over big. So 5. And in the denominator, you can put x, or I'm gonna put v for volume. Doesn't matter. Okay, and then you just cross multiply. 1 times v is just v. So then whatever 5 times 27 is. 135. 135. And the units will be meters cubed. Okay? And instead of triangle, it should have said, well, but then pyramid wouldn't really just have a perimeter. I don't know. This was a badly worded question.